So once we have the x and y coordinates, we can plot those x and y coordinates onto the graph, and we can connect and we create the equation. I spoke about what a function was, which is just an assignment of inputs to outputs, where the input can only be associated with one output. And there's two ways to view it visually, as an arrow diagram or as a machine diagram, using the machine diagram. And we can also represent it as a set of ordered pairs. The set of ordered pairs are just x and y coordinates, right? Paired up. And in a function, the x's appear only once. The y's can appear more than once. So the y values could repeat. The x values cannot repeat. So that's one of those major takeaways. And the x coordinates or the x values are the independent variables, which represents the domain, and the y values are the dependent variable, which represent the range. And then I spoke about the function notation, and we use this f parentheses x a lot, and we pronounce it as f of x. So y is f of x, which means that y is a function of x. In other words, y depends on what x would be. And then associated with that, we talked about evaluating functions, which is just plugging in the x value and finding out what the corresponding y value would be. So I just plug in the x values into the specific places where I see x's, and then I perform the operations to get the final answer. And I realized that I can also evaluate functions at other variables or other algebraic expressions. It does not have to always be evaluated on a number. It could be evaluated on a expression, as we have in this example. And then we found the domain and range of a function. If I have a set of ordered pairs, I can figure out what the domain is by just figuring out what the x values are, because that's what the domain is. And then similarly, I can just find the y value, the range, by finding the y values of the set of ordered pairs. However, when I have a graph, I have to be a little bit more perceptive visually as to what the domain and range is. And when we have a graph, our domain and range will most likely be an interval. It's not just going to be a set of numbers as we had in the previous scenario. When we have graphs, we have to look at the interval of the x values and the interval for the y values. Okay. And then I think we ended with this, the vertical line test. The vertical line test, that is a way to determine whether a graph represents a function or not. So if you have vertical lines that are parallel to the y-axis and they only cross the graph once, then it means that it is a function, because for every one point of intersection, I only have one x value. And remember, x values cannot repeat. However, we have scenarios where the graph is actually cut twice by the vertical line, or more than one, or more than two times. If that's the case, that means that the x value associated that I have here in our graph here has two y values associated with it, and therefore it cannot be a function. So vertical line test helps us to determine whether a graph is a function or not. Okay. All right. So that was a quick summary of what was done in lecture number 4. And let's continue on now with lecture number 5. And again, if you have any questions, any comments, please let me know. I know it's been quite a break here. I feel like there should be no break after this one we just had until spring break. And so I think we're going all the way straight until spring break. All right. So today is the 17th. And yes, and you should all have your quiz grades and your quizzes graded on Google Classroom. Each one should have received it or can check to their Google Classroom to have the grade for the quiz, number 1, and to actually visualize, to see visually what you all got, all the markings that I made. All right. Okay. So we're going to be talking about, in particular, what kind of functions are we going to be considering? We're going to be considering linear functions. So we care about linear functions. So what are linear functions? So linear functions have this form. So they're the functions that are defined f of x equals mx plus b. Or, so this is the function notation. Or you may have heard it as y equals mx plus b. This is called the slope intercept form of a line. And the m here represents something that's called the slope, and the b here represents something that's called the y-intercept. Have we heard of this before? Makes sense? Yes. Okay, great. So if I have an example here, y equals, and I write, let's say, let's write this as 5x minus 3. So this is in slope intercept form. So whenever I see mx plus b, I know it's the slope intercept form. Now, what information do I have? I got the slope and I got the y-intercept. So slope equals 5 and the y-intercept b equals negative 3. Now, I want to graph it. So graph. I want to graph. Now, how do I graph? Before we continue, what is slope? In general, what is slope? Well, slope is a rate of change. It's the change in the y values over the change in the x values. This little triangle here is actually a Greek letter named delta. So delta is a Greek letter. We use a lot of Greek letters in mathematics, and delta represents a change or a difference. So then what we're doing is we're going to be taking the y values, subtracting them, and taking the x values of 2 points and subtracting those. And that ratio represents the rate of change or the slope. So slope is also known as the rate of change. And we normally call this, one way to express this is rise over run. But that's if the slope is positive, and if the slope is negative, we can, instead of rise, you can think of fall over run. So fall over run, and that's when this is negative and this is positive. So I'm going to draw a I'm going to draw this on a separate graph here. So if I have a graph, how do I graph y equals 5x minus 3? Well, I start with, so the first thing is start with the y-intercept. Start with y-intercept. What's this y-intercept? 0, comma, negative 3. So where is 0, comma, negative 3? If this is negative 1, negative 2, negative 3, this is negative 3 right here. So this is my starting position. the y-intercept. This is my starting position. And then I want to figure out what's the next point. Well, I have to use slope to figure out the next point. My slope here is 5. And what we're going to do is we're going to always write our slope as a fraction. So this is 5 over 1. And if remember, this is positive, 5 represents how much I move up in the y direction, and 1 represents how much I run over in the x direction. So this will be from 3, this will be 1, 2, 3, 4, 5. That's how much I move up in the y direction, and then I move over 1 in the. So yeah, let me just get that again. So this should be right here. I'm going to use blue for this. So you guys see that? This is 1, 2, 3, 4, 5, and over 1. And I'm going to do the same thing again. 1, 2, 3, 4, 5, and then over 1. And so on and so forth. And then I can just draw a straight line that connects these points together here. If only I drew this a little straighter. And it doesn't really do a good job. Let's see. Yes. Okay, that's a little better. Let me just shift this a little over like this. Okay. And now this is the graph. Some people like to define this a little bit better here. So these are, this is 1 over, and this is 5 over. And this happens again over here as well. This is 1, and this is another 5. So that's how I plot my graph of linear functions. I start with the y-intercept. That's my starting position. And then I use a slope to figure out the next point. So that's like my command. You can think of them as my my commands. So this I move up, and then this I move right. Up, right, up, right. Any questions about graphing linear functions? If there's no questions, let's see another example. So what if I have, instead, I got y equals negative 3 over 4 plus 2. So I have to identify, and this is negative 3/4 x. So the first thing is my slope, my y-intercept. So the first step I do is start at y-intercept. And the y-intercept is given by 0, 2. The y-intercept again is the point on the y-axis that I cross. It's the point on the y-axis where the line crosses. So 0, 2, that will be right here. So I'm crossing it right here. Okay, now that's the first thing. The second thing is use the slope to find the next point. So now I have to look at it as a command. So my slope here is negative 3 over 4. So negative 3 is associated with moving downward, and 4 is, I still move to the right. So I'm going to be moving 3 units downward. So it's going to be 1, 2, 3, and then 4 units to the right. 1, 2, 3, 4. So I got this here to be 3, and I have another one here to be 4. And then the same thing happens again. So I go 1, 2, 3, and then I move over 1, 2, 3, 4. So this here is 3, and this here is another 4. And then I draw a straight line And these are this is the sketch of my graph. Okay, so this is how we approach any linear, any slope-intercept form, any line that's in slope-intercept form. So any questions about graphing linear functions? Are we all clear about how we use a slope-intercept, how we use the y-intercept and the slope? Is that clear? Yes, 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 yes. Great. All right. So that's when we have it in slope-intercept form. But there's also another form of a line. So let me just write this slope-intercept form. That's one way to look at it. Another way to look at it is in the standard form. So there's something that's called the standard form. AX plus BY equals C. A, B, and C are real numbers. So we have something that's called standard form. So for example, as an example, I want to graph uh, 3x plus 2y equals 6. So again, this is a line. The problem is, or maybe not the problem, but the situation is that this graph here, this equation here, isn't the standard form. But we're more accustomed to graphing it, writing it as the slope-intercept form. So what we're going to do first is convert. So first, convert from standard form to slope-intercept form. And we're going to do this by solving for y. So I want to go from standard form to slope-intercept form. And how do I do that? I want to get y by itself. So I have to do this. So 3x plus 2y equals 6. So I want to get y by itself. So this is my objective. The problem right now is that I have this 3x in front. So I have to subtract 3x on both sides. And when I subtract 3x on both sides, the 3x's here cancel. And I'm left with 2y on the left side of the equation. And I can write it as 6 minus 3x, but normally we have the x here first, the x term first. So I'm just going to write it as negative 3x plus 6, same idea. And then now, because I have this 2 in front, I need to divide by 2, divide by 2, divide by 2. The 2's cancel. And I get that y equals negative 3 halves x plus 3. And so this now is the slope-intercept form. Okay, so we went from standard form. So we went from 3x plus 2y equals 6 and converted it to slope-intercept form, negative 3 halves x plus 3. And now we can graph it. Since we know our slope is negative 3 halves, and we know that the y-intercept is 3. Or in other words, the y-intercept is 0, comma 3. So I'm going to draw this. I'm going to sketch this. So remember, I start my position at 0, comma 3. This is my starting position. And then this represents my commands. This is my command. I fall by 3. And I move to the right. Or I should say run 2 units to the right. So 0, comma 3, I'm going to be 1, 2, 3. This is where I'm going to start. And then I'm going to move down by 3. Let's do it with the blue. So it should be 1, 2, 3, and then move over by 2 to the right. So 1, 2. This is the next one, and then 1, 2, 3, and then 1, 2. Next one, and 1, 2, 3, and then over 2, and so on and so forth. And then I can make a nice straight line that goes to these 4 points. Let me just adjust this a bit, and then voila. This is the graph of my line. So this is graph of 3x plus 2y equals 6. Clear? Is that clear how we're able to graph standard equation of a line? We just have to convert it to slope-intercept form by solving for y. We find the slope, find the y-intercept, plot the points, connect the lines, and we have the graph. Okay. Well, I'm glad everything is understood here. Okay. So let me just give you we have 4 examples of lines, or 4 I guess you can say 4 possibilities for lines. What I mean by that is there's only 4 ways that a line can exist in this space. So the first way, the first kind, is if the slope is positive. So if my slope is positive, my graph will look something that looks upward, right? So this is when I have positive slope. But of course, it doesn't have to be, right? I can have negative slope. If I have negative slope, then my graph will look like a function that's going from up to, it's going downward if I look at it from left to right. So yx. Okay. Now, the third kind, so this is a positive slope, negative slope. The third kind is if the slope is equal to 0. Does anybody remember what happens if my slope is equal to 0? What would the graph be of the line? What if my slope is exactly equal to 0? Does anybody have an idea of what the graph of the line will look like? Straight line. Yeah, these are all straight lines, David. But how would the straight line appear? on the x-axis. It could be on the x-axis, but not exactly. And Amy, I think, and Amelie both got it. They're horizontal. So the idea is that they're parallel to the x-axis. So whenever you have a slope that equals 0, what you have is the following. You have a horizontal line. So that means that it's parallel to x-axis. It crosses the y-axis at some point, and the equation of this horizontal line is y equals b. Well, I'm glad, David, you're thinking about that word. So y equals b is the equation of the line. So horizontal lines is y equals 10, for example. Y equals 5. Y equals negative 100. Y equals a number represents a horizontal line. And finally, so my slope could be positive, my slope could be negative, my slope could equal 0, or my slope could be what? What's the fourth possibility? My slope could be positive, negative, 0, or what? One. Well, 1 is positive, so I already have that possibility. Infinite? Oh, that's an interesting question. Can slope be infinite? Huh. I think you're onto something. We don't call it infinite though, because yeah, it's related to, so it's related. It's related. We don't say the slope is infinite though. That's a very interesting idea. We say the slope is undefined, which you can think of it as being infinite because infinity also is not clearly defined as to what infinity means, at least not for this context. So slope is undefined. If you have a slope that's undefined, what you're going to get is a vertical line. So you're going to get a vertical line instead. And that vertical line is parallel to the y-axis. And that vertical line has an equation of x equals, I'm going to call this k. It's very much similar to the equation of the horizontal line, which y equals a number. In this case, x equals a number. So let me just give you some examples on both. So if, for example, if x equals y equals 4, and if the y equals 4, and if the example is that x equals negative 5, what would the graph be? So we should immediately say horizontal line. Immediately. Why? Because it's y equals a number. And if x equals a number, we should immediately say vertical line. Immediately. Why is that? Because x equals a certain number. So then when we graph this thing, y equals 4, we have 1, 2, 3, 4. So 4. Then draw a straight horizontal line going through the point 4 here. See that? This is y equals 4. Then when we have x equals negative 5, what do we got? 1, 2, 3, 4, negative 5. And this line goes straight vertically. All right, so this is x equals -5. It crosses the x-axis at the point -5, 0, and this crosses the y-axis at the point 0, 4. Okay. All righty. Now, what we're going to be interested in as well is finding graphing a line in standard form using the x and y intercepts. So first of all, what is the x-intercept and what is the y-intercept? The x-intercept and the y-intercept. The x-intercept is the point on x-axis where the line crosses. And it crosses at the x-axis if the y value must be 0. That's another thing I should say. And the y value, or the y coordinate, equals 0. And the y-intercept is the point on the y-axis where the line crosses. And the x-coordinate equals 0. So it's like it switches back and forth. So x-intercept means y-coordinate equals 0. Y-intercept means x-coordinate equals 0. So that's how we're able to figure out the intercepts, by knowing what the corresponding y or corresponding x value is. So I'll give you an example. So suppose I want to graph 3x plus 4y equals 12. Negative 12. Now, what we could do is what we did earlier, right? We could solve for y. Get y by itself, rewrite it in slope-intercept form, and move on with our lives. However, we're going to do it a different way. So there's actually two ways to graph a line in standard form. One way is using the slope-intercept form, converting it to slope-intercept form. And the second way is using the standard form by way of plotting the x and y intercepts. So I'm going to graph by plotting x and y intercepts. So I need to find the x-intercept. Now, to find the x-intercept, what's important is to realize that y must equal 0. First thing. So find the x-intercept, y equals 0. So if the y equals 0, then well, look what I could do. I can write 3x plus 4 times 0 equals negative 12. So find the x-intercept. So what I'm going to do is, the first thing is set y equal to 0. And the second thing is solve for x. So this becomes 3x equals negative 12, divide by 3, divide by 3. And I get that x equals negative 4. So then, what's my x-intercept? It's going to be negative 4 comma 0. So that's the first piece of information that I have. Okay. That's the x-intercept. And now the second thing is find the y-intercept. What's the y-intercept? That's when x equals 0. So what am I going to do? The first thing is set x equal to 0. The second thing is solve for y. So then I'm going to have 3 times 0 plus 4y equals negative 12. 3 times 0 is 0. 0 plus 4y equals negative 12. 4y equals negative 12 divided by 4. And the result is that y equals negative 3. So then what's going to be the y-intercept? The y-intercept is going to be 0 comma negative 3. So we have the two intercepts. You see that? We got the y-intercept and the x-intercept. Now, once I have those two intercepts together, I can plot. I can plot them. So the first intercept, the y-intercept, is 0 comma negative 3. So I have something right here. And then I have the y-intercept, which is negative 4 comma 0. And then this point here, it's negative 4 comma 0. This point right here, that's 0 comma negative 3. This is the x-intercept. And this is the y-intercept. Once I have those two things, all I need now is a straight line that connects these 2 points. And voila. I have the graph of 3x plus 4y equals negative 12. And we're good. So do you understand now how I'm able to use the intercepts? So I can use intercepts to graph equations of lines in standard form, of course. And the important part here is to note that the x-intercept is when y equals 0, and the y-intercept is when x equals 0. So that has to be sticking in your head. All right. So again, if you have any questions, please let me know. Any clarification, just raise your hand virtually, I guess, and or type in your chat box. Okay. So the next thing I want to talk about is called the zero. The zero of a function, and in particular, we'll be talking about a linear function. It doesn't always have to be linear, but in this case, we're talking about linear functions. So what's the zero, quote unquote? The zero of a function is the x, is the x value that has a y value equal to 0 in a function. So I should mention that here is the x value for a function f of x that has a y value equal to 0. So example, let's suppose I want to find the 0 for f of x equal to 4x plus 6. Let's say I want to find the 0, right? I want to find the x value. It's just, guys, we just have a lot of vocabulary that we need to know. So the zero of a function is the x value that makes the y value equal to zero for a function. So in order to find what that x value is, y equals 0. Huh. That sounds very similar to something, isn't it? The 0 is also aka the x-intercept. But we have so many different words for the same thing. So the x-intercept represents the 0 of the function. Except that it's a bit more specific. The 0 is the x value of the x-intercept. So maybe I should write that. It's the x coordinate of the x-intercept. So then what I'm going to do is I'm going to set f of x equal to 0. And then secondly, I want to solve for x. So I'm going to say this. 4x plus 6, that's f of x, right? This here is what f of x equals. This equals 0. Solve for x. Subtract 6, subtract 6. 4x equals negative 6. Divide by 4, divided by 4. So x equals negative 6 over 4, which reduces to negative 3 halves. So then what's the conclusion? The conclusion is the 0 of f of x is x equal to negative 3 halves. Okay, so the 0 of my function is when x equals negative 3 halves. Why is it the 0? Because when I plug it in, when I plug it into the function, I get that my y value is 0. When you hear the word 0, you think about y equals 0. What's the x value that makes the y value equal to 0? So that's what the 0 represents. Okay. So we have that down. Now, what we need to study a bit more is this idea of slope. So what is the slope?
Rise over run.
Right. So I want to find slope again. I want to revisit slope a bit. And again, I'm going to write it. Slope is given by the m value, which is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. It could be rise over run, but that's if it's a positive number. So if, so I'm just gonna write this as two separate things. So this is if slope is positive, but it could also be fall over run, and that's if slope is negative. Okay. Okay. So I want to calculate slope between 2 points. So how do I calculate between 2 points? So let's suppose I have a point. I have 2 points. One of the point has the coordinates -1, 3, and the other point has the coordinates -4, 5. So these are 2 points in space, right? So if I were to draw this or sketch this, -1, 3, I would be -1, 3 somewhere here. And then I have negative 4, comma 5. So I'm right here. So I have these 2 points. And I want to figure out how steep would a line that goes through it. How steep is it? So then I need to find the slope. Slope is the change in y over the change in x. y2 minus y1 over x2 minus x1. Now the question is, which one is the x2, which one is the y1? Which one is the y2, y1, and which one is the x2, which one is the x1? So this is where you can kind of just flip a coin and say, hey, I want this top one here to be x1. But if I say if this is x1, then this has to be y1. So you have to pair up the number, the subscripts, you have to pair them up. And if that's x1, then this has to be x2, and this has to be y2. If I were to change, just swap these, if I swap them, the slope that I calculate will still be the same value. It doesn't change. I just have to be consistent with, if I choose this to be x1, this has to be y1, and so on. So now I use a formula. Y2 is 5, y1 is 3, x2 is negative 4, minus, and then x1 is negative 1. So 5 minus 3 is 2. 4 minus negative 1 is negative 4 plus 1, which would be 2 minus 2 over negative 3. So that's the slope. So I calculated the slope between the 2 points. It's negative 2 negative 3, 2 divided by negative 3. And again, this can also, 2 over negative 3 can also be written as negative 2 over 3, or it can also be written as negative 2 over 3. So this negative symbol here can be placed either at the numerator or denominator or on the side. They all mean the same thing. So that's one thing to note. Okay. Okay. So finding slope is pretty straightforward as long as you know the formula. What if I had the following points here? So I want to calculate slope, right? So what if I have the points 3, 4 and 0, 4? What would be my slope? So m would be the change in y over the change in x, y2 minus y1 over x2 minus x1. So y2 would be what? I have to make a decision, right? x1, y1, x2, y2. So this would be 4 minus 4. And then over, and then x2 would be 0 minus 3. 4 minus 4 is 0, and 0 minus 3 is negative 3. But 0 divided by anything is 0. So what's my slope? My slope is 0. And then what can you tell me if my slope is 0? What's true? If I have a slope equal to 0, what kind of line would connect 3, 4, and 0, 4? Remember, if I have a slope equal to 0, what would be the line? It would be a
horizontal line.
Thank you. Who was that? Can you say your name?
Maria.
Maria. Thank you, Maria. So it's a horizontal line. Good. Thank you, Tyler. Yes, that's right. It's horizontal. And then we have just one more of these. I'm pretty sure you guys understand. So how do you use the formula? So negative 3, negative 1 and negative 3, 4. Again, I want to find the slope. The slope is the change in y over the change in x, y2 minus y1 over x2 minus x1. And I'm just going to switch this around a bit. This is going to be x2, y2, x1, y1. Again, I don't have to always call this x1. I can call this x2. I still get the same answer at the end regardless. I just have to be consistent with naming them. So y2 here would be -1 minus 4 over, and then x2 would be -3 minus -3. And when I do that, I get -5 in the numerator, and I get -3 plus 3. But when I get that, I get -5 over 0. And what's -5 divided by 0? Zero. Or is that true? So I got two people saying zeros and I got two people saying undefined. So it's 50-50. So who's right? Who's wrong? Rock, paper, scissors. Maybe that works. Oh, we're having a lot more now. Okay. Yes. This is undefined, guys. Undefined. It's undefined. According to the laws of mathematics and arithmetic, dividing by 0 is an impossibility. It doesn't make physical sense. How do you divide by nothing? So because of this kind of limitation of arithmetic, we say, hey, you know what? I don't know what that is. So we call it undefined. So when you divide anything by 0, you have an undefined value. When you take 0 and divide by anything, you get 0. It's a very big difference. It's a big difference to have 0 being divided by a number rather than being divided by 0. So if you have 0 in the numerator, the result will be 0. If you have 0 in the denominator, the result will be undefined. And if my slope is undefined, what kind of line is associated with it? So if slope is undefined, what's the line? It's a vertical line. Very good. So we have a vertical line. And let me ask one step further. What is the equation of this vertical line? Who would know the equation? Remember vertical lines? What's the form of a vertical line? What's the equation of a vertical line? And then I'll ask the same thing here. For the other example, what would be the equation? X equals -5. See here, that's for the vertical line. So you're right in saying that X is equal to a number. That's right. But it's not -5. It represents the X coordinate. That is right. If you notice, look what they have in common. They have the same X coordinate of -3. And therefore, the equation will be what? X equals -3, just like that. Right? Say that again. Yeah, of course. So I want to find the equation of the line that connects those 2 points, right? So you know what? What if we sketch it really quickly? What if we sketch these 2 points in space? So that's why drawing stuff out helps a lot. It may seem like it doesn't help, but it does. -3, right? The -3 comma -1. Look where the point is. It's right here. And then I have -3 comma 4. Another point right here. If I were to draw a line connecting these 2 points, what would I get? Vertical line. But the question is, what is the equation of the vertical line? Well, the equation of the vertical line is exactly the x value for each of these points. But the x value for any point, I don't care what it is, for any point on this vertical line will always be x equals -3. And therefore, the equation will be x equals -3. So graphing it helps just to give you that kind of visualization. Now, let's go back to the example that we just did where the slope was equal to 0. If the slope was equal to 0, it means that a line that's horizontal connects these 2 points together. Now, my question would be, what's the equation of that horizontal line? What would you guys now say for that? So remember, horizontal lines have y equals in it. But what would y equal? 4. Yes. Yes. 4. 4 is in both of them. The y values match. So y equals 4. Done. You guys see that? So when you have a horizontal line, what's the equation for the line? Just look at the y coordinate. If you have a vertical line and you want to know the equation of that vertical line, what do you look at? Just the x coordinates. That's how simple it is. That's how simple the equation is for vertical lines and for horizontal lines. Now, we're going to get into a bit more complexity. Is when we want to find equations, finding equations of lines that are not necessarily vertical nor horizontal. They're like slanted. So what if I want to find the equation, of a line that has the following. The first thing is the slope. I'm giving you the slope. The slope is -1/3. And I'm going to give you that it goes through the point. Goes through point. And the point here I'm going to give you is -3, -2. Now, how would I find the equation of a line? What I'm going to use now is a new form. I'm going to use the point slope form. So keep in mind, keep track. How many different forms of a line do we have? We have 3 so far. The first one is the slope intercept form, y equals mx plus b. The second kind is the standard form, ax plus by equals c. And then the last of its kind is the point slope form, which is y minus y1 equals m multiplied by x minus x1. This is the point slope form. Okay. So look what we got. We got the slope, check. And then we got 1 point. I'm gonna call this point x1, y1. I don't need an x2 and y2 because I don't have another point. I only have 1. So I have a point, I have a slope, hence use point slope form. Now plug in. So I got y minus parentheses -2 equals -1/3 parentheses x minus parentheses -3. So all I did was I plugged in the y value of the point, the x value of the point, and the slope. That's all I did. And then I'm going to simplify a bit more. So this will be y plus 2 equals -1/3 x plus 3. And guess what? I'm done. This is the point slope form. This is it. It's in point slope form. But what we could do is rewrite this in the form that we're more comfortable with, which is what? Slope-intercept form. So now I want to convert. Now convert point slope form to slope-intercept form. And I'm going to do this by solving for y. And when I say solving for y, I mean get y by itself. So what do I have? I got y plus 2 equals negative 1/3 x plus 3. So I want to get y by itself. The first thing is I still have to take care of this parentheses. So I get negative 1/3 x plus negative 1/3 times 3 becomes minus 1. Right? So let me just write this. Negative 1/3 times 3 is negative 1. So that's why I have the negative 1 here. And I still have this y plus 2 here. So I subtract by 2, and I get that y is equal to negative 1/3 x plus 3. And look what I just accomplished. I accomplished rewriting the slope-intercept form, the point slope form into slope-intercept form. Okay. So given a point and given the slope, I can find the equation of a line by the point slope form of the line. And then I can convert it to slope-intercept form just by solving for y. Okay. Isn't it negative 3? Tyler, the x1 is negative 3, but if you look closely at the formula, this is x minus x1, right? So what I'm saying is I'm taking x, subtracting it from negative 3, because the x1 value is negative 3. But when I do x minus negative 3, this becomes x plus 3. I don't know if that answers your question. And then you distribute the negative 1/3, and then this becomes negative 1, and then we, oh, I see. That's what you're saying. You're right. You're right, Tyler. It is minus 3. I don't know why. Yeah. I was looking at something else. I was distracted by, no, I'm just playing. Yeah, minus 1 minus 2 is minus 3. You're right. And then from here, what kind of information can I figure out? I can figure out, for example, the slope is negative 1/3, right? And I can figure out that the y-intercept is 0, negative 3. So there are things that I can also learn from the graph of this line by having it in the slope-intercept form. Okay. Okay, great. So good. We're making a lot of headway into this. Now I'm going to give you probably the hardest version of this kind of task. So the hardest version of this task is when you only have 2 points. You don't have the slope and 1 point. So I want to find the equation of a line. Find equation of a line. Using only 2 points. So what if I only have 2 points? So here are the points again. Remember we talked about this? We only have 2 points. Let's give you a better one. I'll give you two examples for this. So let's start a little bit. Yeah. So what if I have points 4, 1, and I got the point 3, -2. I want to find the equation of a line that connects these 2 points together. Like I want to find it. So the first thing is, so step 1 is find slope. That's the first thing I need to find. Why is that? Because for any of these forms, slope is essential. Slope is what usually is given to us, except that when we have 2 points, we don't have the slope. We have to calculate it on our own. So we have slope, and that's equal to what? The change in y over the change in x. y2 minus y1 over x2 minus x1. And I can call this x1, then this has to be y1. I call this x2, this has to be y2. And then I get y2 is -2 minus 1 over 3 minus 4. This is -3 over -1. It should be +3. So what's the slope? It's 3. Wow, that gives us a lot of information so far. So my slope equals 3. Great. Now if my slope equals 3, I still have to figure out the y-intercept, right? Or I can use the point slope form. We just talked about it. Why is the point slope form good? Well, I have my slope, check. And I have one of the points, check. I can choose either. So now for this, guys, I can choose either these two coordinates or these coordinates. It doesn't matter. But since I already have it written as x1 and y1, might as well just use 4, 1. But what I'm saying is I don't have to use only 4, 1. I could use 3, -2 in the point slope form. So I got y minus y1 equals m times x minus x1. So I'm going to plug in y1 will be 1, m would be 3, and this would be x minus 4. So I am done. If I find the point slope form of the line, I'm finished here. There's not much that I need. There's not much else that I need to do. Done. However, if I want to write it in slope intercept form, so this is point slope form. If I want to write it in slope intercept form, then I need to solve for y. So solve for y, I need to now distribute this 3, right? I distribute the 3. And then I get 3x minus 12, y minus 1, add the 1, add the 1. And I get that y equals 3x minus 11. And now I have this in slope intercept form. And with the slope intercept form, what can I learn? I can learn that the slope is 3. Well, I already knew that. And I can find that the y-intercept of this line is 0, -11. Okay. Any questions about finding the equation of a line using 2 points? Find slope, apply the point slope form. You get the point slope form, and if you need to write it in slope intercept form, we just solve for y. All right. Any questions about this? All right, so sounds like it's crystal clear.